Welcome to Programming with Python session 10. Before we move ahead with the session, I would like to introduce you to a couple of things. One is our website, Technolearnit. This is our website. You can visit this website to get more details about who we are and what we offer. And if you want to get in touch with us, this is a page where you can use different channels to contact us. And then, most importantly for you, the resources page where you can download the resources that have been used in these sessions for free, and you can practice those exercises from the sessions and become better programmer. And also the same page will also have the information about the next live event date and time, so keep an eye on this page so that you will be up to date with the latest information. All right, with that said, let's move on with the session. Today we're going to talk about tuple. So let us take some practical example. Assume that you have a class of students and you want to store the roll numbers of 60 UKG students, right? So how can you achieve this? One way is to create 60 individual variables. However, sometimes it may not be practically possible because the number of students may increase to 500 or 1000 or 2000. Creating 2000 individual variables and managing them is very difficult. That is where tuple comes into play. All right, what is a tuple? Tuple is a collection of multiple values stored in single variable. This is the exact same thing that we are looking for, right? So it can hold multiple values, but it can be referred as with a single variable, right? And tuple is a built-in data structure. It stores ordered collection of items. It allows duplicate items. It can also store items of different data types. And to create a tuple, we use braces. I'll show you this with an example. And all the items that belong to a tuple have to be separated by comma. Okay. And tuples are indexed. Indexed meaning items can be accessed by their positions using indexing, right? And most importantly, tuple is immutable. Tuples are immutable in Python, meaning once you construct a tuple with certain items, you cannot replace those items or you cannot modify those items within that tuple, maintaining the same tuple ID. Okay, we'll see this with practical example. And finally, the tuples generally are little bit faster than lists. All right, with that said, let us look at the syntax and examples. To create a tuple, you need to mention some tuple name, and then you need to use braces to enclose all the items that belong to the tuple separated by a comma. And that is the syntax that you see here. Left hand side of the assignment, after you have tuple name, and on the right hand side you have all the elements or the items that belong to the tuple enclosed within braces and separated by comma. An example: marks is the name of the tuple here. 92, 89, 67, and 90 are the items or elements of this tuple, and you can clearly see that these items are separated by comma and enclosed within braces. So marks becomes a tuple now. Similarly, if you want to store attendance, here attendance is the name of the tuple, and all the elements that you can see are separated by comma and enclosed within braces. Height is another example where height is the name of the tuple in this example, and 40.5, 39.2, 41.3, 40.0, these are all items of the tuple separated by comma, again enclosed within braces. Promoted is another tuple with 4 items in it, and all the items are of type boolean. All right, name is another tuple where you have names of people and the items belong to string type. So statement 2, it is a tuple of integers. Statement 3, tuple of integers again. Statement 4, tuple of floats. Statement 5, tuple of booleans. Statement 6, tuple of strings. And since tuple can support its items to be of different data type, on statement 7 you can see an example, the tuple named by data, which has different types of data associated with it, right? So 92 as an integer, the item 40.5 is a float type. Prove another item which is of boolean type, abhi, another item within this tuple data is of type string. So tuple allows us to store different types of data to be saved. All right, before we get on to indexing part, I would like to show you some practical things, how to use tuple, so on and so forth. Say for example, I create a tuple 1 in IDLE. How to create tuple? You need to use braces, and I want to create tuple with 5 values. Okay, and now look for the type of tuple 1. Tuple 1 is a variable name, right? So you see it is of type tuple, right? You can create one more tuple with some different values, maybe 10, 13, 15, 9, 6, some random numbers I'm just giving. And you can also ask for the type of tuple 2. You can see it is also a tuple. So this is how you can create tuples, and you can create tuples in a different way using the keyword tuple. And if you are going to use this, you need to pass a list. And here I am also repeating some elements just to show you that tuple allows you to store duplicates in it. Again, ask for the type of tuple 3. Yes, it is a tuple. So to create a tuple, either you can use braces and mention the items within those braces separated by comma. Otherwise, you use the keyword tuple, again use braces and pass a list as argument to that tuple, so that that entire list will be converted into tuple, right? And as you see here, tuple allows you to store repeated elements. So tuple can have duplicate values. I'm going to create one more tuple now of different types. This is an integer, this is a float, and I want to store false, which is a boolean type, and I want to store a string like this. Again, ask for the type of tuple 4. Yes, it is a tuple. That means tuple can store duplicate values. Tuple can store elements of different data types, right? Now, what if I create like this? First of all, is it considered as a tuple? Yes, it is treated as tuple, right? What if I create another tuple and I just want to have only one element in it? Say I want to store 34 in it. So tuple 5, it is called empty tuple because it doesn't have any single element within it, right? It is an empty tuple. To create an empty tuple, this is a syntax. Now, if you have to create a tuple with single element, is this the syntax? Let us try. Ask for the type of tuple 6, right? Ask for the type of tuple 6. Let us see what it gives us. Interestingly, it did not treat tuple 6 as a tuple, but it treated it as an integer. Why is this? Before you understand the reason, say you have x is equal to 2 plus 3, and now if you ask for the type of x, it's an integer. Again, you have 2 plus 3 this time kept in braces. What would be the type of y? It is again an integer, because this expression that is enclosed within braces has been evaluated to an integer. Now, what if I just have some number or digit like this without any expression? Of course, this is also treated as an expression in this case. And if you ask for the type of z, it treats it as an integer. Same thing happened in this case. You have considered one element and you have assigned it to a variable, and that variable has been treated as an integer by Python. Same as this situation. If that is the case, does it mean that I cannot create tuple with a single element? Not really. There is a way. What to do for achieving that is, yes, of course, you create single element tuple, but make sure you add a comma after that. Now look for type of tuple 6. Yes. Now it has been treated as a tuple, right? So it's not braces that decides that it is a tuple, but it's a comma, right? That indicates that it's a tuple. Interestingly, what if I don't use braces? No error, but let me look for the type of tuple 7. Yes, it is a tuple. That means braces are optional, right? I can create a tuple just by mentioning some values separated by comma, right? So if you ask for the type of tuple 8, treats it as a tuple. It means that if I want to create a tuple with single element, does this become a tuple? Not really, because now if you look at the type of tuple 9, it is treated as an integer. But if you store same element by also mention a comma, and the sorry, okay, anyways, the name has been given Tuple. I'll use the same name. It's just a variable name. No, you can give anything as long as you adhere to the rules to be followed while naming the variables. See, now this has become a tuple, right? So it's a comma that really treats the elements as tuple elements, but it's not just braces. Braces are really optional, as I have shown in these examples. Make sense? So this is how you can create tuples. I have shown you how to create empty tuple. I have shown you how to create a tuple with single element. I have also shown you how to create tuple with multiple values. I have also shown you how to creating tuples with elements of different data types. With that said, let's move on. Okay, this is something relative indexing. Now, I say for example, I have created a tuple by name numbers. I have created a tuple by name numbers. So numbers is equal to I have provided all the elements within braces separated by comma. Now automatically each and every element based on its position within the tuple, it gets some integer value starting from 0. Those are nothing but, those are called indices. 0 is an index, 1 is an index, 2 is an index, 3 is an index, 4 is an index, and 5 is also an index. So these are all indices. Using these indices, you can access these elements, individual elements. What if I am not interested to get all the elements from the tuple, but I want to get a specific element from the tuple? That is where indexing is helpful. So indexing is of two types in Python. One is positive indexing, and the one that you see here right now is a positive indexing. Positive indexing starts with 0 and goes up to anything based on the number of elements that tuple has. Make sense? Similarly, there is something that Python supports which is called a negative indexing. Negative indexing is basically this one, what you see here. Negative indexing is something like this. So negative indexing starts with -1, and remember, negative indexing starts with the rightmost element or the last element in the tuple, and it keeps reduced from right to left. It keeps reducing. You see? Whereas positive indexing starts from the very first element on the left and keeps increasing from left to right until you reach the last element within the tuple. So Python supports both indices, positive indices and negative indices. Make sense? All right. Now, if you have to really access 25, the element, again, 25 is repeating. So let me take an example of 30. If you have to access 30, all that you need to do is you need to ask for number within square brackets, you need to mention 2. Okay, now look at this statement. Okay, numbers is the name of the tuple, and within the brackets you mentioned 0. That means what is the element that you are interested in? What is the element that you want to access and print? It is nothing but 48, because at 0th index you see an element 48. All right. And what is the element at index -6? It is the same 48, right? So like this, numbers of 3, again, what is the element at index 3? It is 64. What is the element which is at index -3? That is also 64, right? And if you look at the element at index 5, it is 25, and the element which is at -1 is also 25. Like this, the same element can be accessed using positive index as well as negative index. It's up to you based on your convenience, based on what you are doing. Now these are the operations that we are going to learn on tuples. I have shown you how to create tuple with parenthesis, already covered. How to create tuple without parenthesis, covered. How to create tuple using tuple and braces, that is also what we have already covered. Next one is indexing. I just covered what indexing means. Now I'll show you how to use that indexing. If you want to print what is there in tuple 1, these are the elements that are available in tuple 1. Now what if I have to access 1 from that? So 1 has an index of 0, because 1 is the very first element in this tuple and indexing starts with 0 on the left. So you see, sorry, it is tuple 1, no, I misnamed the name of the tuple. So tuple 1 of 0 gives you 1, right? Let us create, or let us overwrite tuple 1 with some random numbers. Okay, tuple 1 is 13, 15, 6, 98, 34, and 16. Now what are the ways to access 13? One is I may ask for tuple 1 of 0. So 0 is index, right? At 0th index, what is it you have? You have 13. That is why you get 13. How can I access this same 13 with negative indexing? Of course, negative indexing starts from right. This is -1, -2, -3, minus 4, sorry, minus 4 and minus 5. So when I ask to give me the element at minus 5, I should get the same element. Yes, it is same 13, right? And what if I ask for tuple 1 of 3? What is there in third index? Again, it is positive index, so start from left. This is 0, 1, 2, 3. It is 34, right? So you get 34. And what is there at minus 1 index? Mhm. Minus 1 index. At minus 1 index, you see 16. So 16 is what you see here, right? You get here. This is how using indexing you can access the elements from tuple, individual elements, individual items, right? If you want to access only one item from tuple, use its corresponding index and mention that index within square brackets appended by the name of the tuple. That gives you the elements from that tuple. And if I want to find the sum of first and last elements in this tuple, how can I do that? Tuple 1 of, where can I find the very first element at 0, right? Plus tuple 1 of course, minus 1 is what you can refer to. One sometimes positive, sometimes negative indexing. Yes, it is possible. You will see it as a 29 because 13 is the very first element, 16 is the very last element. 13 plus 16 gives you 29 is what you see here. So you can access individual elements from this tuple and perform operations, any arithmetic operations or any kind of conditions you can check and so on and so forth. All right. This is how you can use indexing to access elements from tuple. All right. The next one is immutability part of tuple. Let us look at the immutability part of tuple. Okay. So again, I'm printing the values of tuple 1. This is the list of items or a set of items or group of items that are part of tuple 1. Correct. What if I want to update with the very first element, which is right now 13? I want to update it with, sorry, this is at index 0. I want to update it with 23. So if I try this, you see, you get an error. What does it say? Tuple object does not support item assignment. Tuple object does not support item assignment. It itself indicates that you cannot update a tuple element once the tuple is constructed. That is why we say tuples are immutable. Immutable meaning you cannot change them once. You cannot change the elements of a tuple once it is created. But what if I have to really change it to 23? Of course, what you need to do is you need to create it again fresh. How? You wanted the very first element to be 23 and remaining elements as it is, right? So you can repeat the same elements this way. 4 and 16. Sorry. This is allowed. Why is this allowed? I'll tell you the reasons. Every variable in Python has something called ID, and that is a unique identification number that you can get for every variable. Now I am asking for what is I am asking for the ID of tuple 1. At this point of time, you have the ID of this tuple to be this number, right? And what if I change the element, the first element, maybe I'll change it to 13, right? And rest of all, I'll keep them as it is. 16. All right. It allows no problem, right? Now you can see what is there in tuple 1. The first element would be 13 only, not 23, because I have replaced this 23 with 13. But remember, is this really a replacement? Let us see. What is the ID of tuple 1 now? See, it has changed. The ID of tuple 1 has changed. That means this tuple variable is different than this tuple variable. It has completely changed its ID, right? That is why we cannot just update the elements within a tuple by assignment operator, but if you want to make some changes, you have to just do something like this, right? In contrast, let me have a list. with the same elements as 23, 15, 98, 34, and 16. This is list 1, right? And if you look for ID of list 1, this is some ID you got. What I'm going to do now is I'm going to update, because on lists update is possible. I'm going to update 23 with 13. 23 means it is at 0th index. What I'm asking it is, this statement says that go to 0th index in list 1 and assign 13 to that value. Okay. Sorry, I did not create a list, but I have created a tuple. The name of the variable is just a list. It is my mistake. List 1 is equal to create a list, you need to use square brackets. I'm going to create this list once again. 98, 34, and 16. Yes. Now, if you ask for the ID of list 1, you got some number. Perfect. Now I'm going to update the 0th element in this list to 13. Yes, it is allowed. Now, if you print the list 1, you can just see that the very first element has been changed from 23 to 13. However, if you look at the ID of this list 1, it is same as earlier. It is same as earlier. That means any operations that you perform on lists will be in place operations. Whenever you update the list like this, those are all in place operations. That means ID won't change. Within the same space, within the same uh, space of memory, the changes will happen, right? Right? That's the reason ID did not change. Whereas when it's come to tuple, if you just change one element, at least one element of the tuple, and you assign that same to the same variable or a different variable, doesn't matter. The ID immediately changes. Okay. This indicates that once you create a tuple, you cannot change the elements within it. If you change it, the only thing the only way to achieve that is you can mention the new elements, but the ID will change. That's what you clearly see here. Before you update created this new tuple with 13 and rest of the elements being same, ID was different than the later. When it comes to list, it is same even after you performed the update operation. This is a key difference between lists and tuples. One of the main differences is that mutability part and immutability part. Lists are mutable, meaning once you create a list, if you want, you can change the values within that list, right? By simply using this assignment statement. Okay, mention the index in which you want to update the value and mention the new value within that index that to be stored. And that will happen, no errors, because it's a list and the ID would be the same. ID won't change. When it comes to tuple first of all doesn't allow you to update any elements. So if you try to create another tuple and assign to the same variable, the ID changes. That means this is not in place operation. A completely different place is decided to store this tuple. Okay, so that is how lists are different than tuple. All right. So this is all about immutability part of tuple, right? Once you create a tuple, you cannot change its elements. But you may ask, you have changed the elements, right? I have changed the elements, but that's a different story. But that happens because the ID has changed. So the only way if you have to change some of the elements within this tuple is to create a new tuple with the new elements, right? But ID changes. That's what you need to understand. Well, that's all about immutability and then accessing the elements and printing the elements from a tuple, right? As I have shown you already, I have a tuple one, and if I have to print all the elements of that tuple, if it is from IDLE, you can directly mention the name of the tuple. This is what you see, or you can use print function and you can pass that name of the tuple. This also gives you the same output, right? And what if I want to access individual elements? You can, if it is in ideally directly, you can mention tuple 1 of index, mention the index. Say I want to access the element at index 1. At index 1 you have what? 15 1 5. So that's what you get. What if I try to access the last element? Last element can be accessed by using -1 negative indexing, which is 16. Sorry, I need to mention the name of the tuple properly. Tuple 1 of -1. You get a 16 value here, right? You get last element in this tuple is 16, so that's what you get. And what if I ask for tuple 1 of 10? Do you really have an element at 10th index in tuple 1? Not really. So this results into an index error because you have given an index which is not available within this tuple. What is the maximum index within this tuple 1? 0 1 2 3 4. 4 is a maximum index because 0 at 0 index 13 is there, at 1 index 15 is there, 2 index 98, third index 34, fourth index is 16. So but you have mentioned some index which is greater than 4, so you will be getting this index error. Same thing goes with negative indexing as well. If you ask for what is a minimum negative index, maximum negative index is -1, -2, -3, -4, -5. I will ask for -6, which is not available within this tuple 1. So this also results into the same index error, right? So while you are using indexing, be careful, and it is your responsibility as a developer to provide meaningful indexing and valid index value while accessing the elements from a tuple, right? And you can also use print with tuple 1 0, right? And you can access any number of elements like this. I now access the value from fourth index, and I will also access some elements with negative index. I would like to get the last element from tuple. I'm using -1 for that. Tuple 1, sorry, the variable name is tuple 1, and any random elements I'm accessing, just that's all. I am trying to access element with -3. Make sure you understand this. Tuple 0, what is there at index 0? It is 13, yes. What is there at index 4? 0, 1, 2, 3, 4, 16. This is what you see. What is there at -1? That is also 16, right? And what is there at -3? This is -1, -2, -3. It is 98, and that's the reason you see this 98 printed here. This is how you can access elements from a tuple, right? If you want to access the entire tuple, you can pass that entire tuple name to print function, or you can also mention the name of the tuple at the prompt if you are using IDL. And if you want to access individual elements from the tuple, use indexing. The next one is membership operator. So again, let me show you what is there in tuple 1. These are the elements in tuple 1. If you want to know if 13 is present or 15 is present in this tuple, you can ask the membership operator is in that I'm using here. 15 in tuple 1. You're just asking, is 15 present in tuple 1 is what you are questioning. So that is what membership operator really acts as. So here, yes, 15 is present in tuple 1. So you get the response as true. This membership operator returns you a boolean value, either true or false. I'll ask whether 17 is in tuple 1. Do you see 17 in tuple 1? No. So now it returns false. It gives you false. The result is false, right? So in operator is called membership operator, and this membership operator returns either true or false, a boolean value based on whether the element that you are looking for or searching for is present in the tuple or not. If the element is present in the tuple, it returns true. If the element is not present in the tuple, it returns false. Okay. The second thing is a membership operator is not in. It is just applying not. Okay. So now what you're asking is, tell me if 17 is not in tuple 1. Yes, 70 is not in tuple 1, so it returns true in this case, right? And if you ask whether 15 not in tuple 1, it should return false because 15 is present in tuple, but you're asking not in. You're looking at not in, so it returns false. This is how membership operators can be used to check whether a particular element is present in a tuple or not. Okay, simple thing. Say I have created a tuple with fruits, name of the fruits. So you have banana, you have apple, you have mango, okay, and you also have orange. Okay, so if you look at what is fruits, this is what you see. Fruits is a tuple, and you can also use print to print fruits. Same thing, right? And how can I access my apple from this? To access apple from this, you have to mention the name of the tuple and index of apple. Index of apple is 1. So you can ask like this, right? Now, I want to know if mango is present in this tuple or not. So how do I do that? I have to ask if mango in fruits. It returns true because mango is present there. Okay. I want to know if grapes in fruits. Grapes not present in fruits, so you get false. Grapes not in fruits will give you true because grapes is not present in fruits tuple. Okay. What if I ask if banana not in fruits? It is false because banana is present in fruits and you are saying you are asking to check whether banana is not in fruits, but banana is in fruits, so it has written false. This is how you can use membership operators to check whether a particular element belongs to a particular tuple or not, or whether a particular element is present in a given tuple or not. All right, the next one is functions and methods that we can use on tuples. Yes, let us look at tuple 1. You see these elements. How many elements do you see in this tuple 1? 5. So if you want to know the number of elements in tuple 1, you can use len function. See, it gives you 5 because it has 5 elements in that. How many elements are there in tuple 2? 6. So if you ask for length of tuple 2, it gives you 6. So len is a function that you can apply on tuples as well, right? And what it returns is the number of elements that are present in that given tuple, right? And what if I create an empty tuple like this and ask for length of tuple 3? Since it has no values, it should give you 0 because it has 0 elements in it. This is how you can use length function on tuple 3. All right. What if I create a tuple with single element? You know how to create a tuple with single element. Okay. This is how you need to create a tuple with single element. And if you ask for the length of tuple 4, it should give you 1 because it has one element in that. All right. This is how you can use length function. Okay. And you can also find minimum of tuple 2, any tuple. Basically I'm using tuple 2 here. So in tuple 2, what is the minimum element? You see tuple 2 has all these values, right? Out of all these values, what is the minimum element? It is 1. So you can use min function on tuples. You can also use max. So maximum is 15. Among all these elements, 15 is a maximum, so you get maximum like this. Okay. You can also use a sum. Sum is 54. 10 plus 13, sorry, yeah, 23, 23 plus 15, 38, 38 plus 9, 47, 47 plus 6, 53, 53 plus 1, 54. So you can use these functions length, min, max, and sum, right? All these functions are applicable on tuple. Similarly, when it comes to members or the methods, okay, member functions or the methods, what you should do is you should first mention the name of the tuple. So tuple 2 dot dot is what you need to use, and I want to know how many times 9 has occurred within this tuple. 9 has occurred only once within this tuple. Tuple 2 in tuple 2 in tuple 2, how many times 9 has occurred is what you are asking. So it has occurred only once. Let us see if there is any duplicate in tuple 1. No duplicate in tuple 1. Is there tuple 3? Tuple 3 is single element, I guess. No? Okay, empty. Sorry. And okay, let me create or update this tuple 1. Some, okay. This is your tuple. Now, if you want to know in this tuple how many times 1 has occurred, this is what you need to ask. Okay, in tuple 1, the count, what is the count of 1? So 1 has occurred twice, right? That's why you see it as 2. Okay, count will count for that given argument within the tuple and give back the integer value. And in tuple 1, how many times 12 has occurred? 12 has occurred 0 times. There is no 12 at all in this entire tuple, so it has given you 0. In tuple 1, how many times 0 has occurred? Yes, 0 has occurred once. 0 has occurred once, so it has given you 1 as output. So count is a function. Okay, count is a method that you can apply on tuple, right? The other one is index. Say for example, let us again go back to tuple 2. In tuple 2, these are the elements. What is index of 13 here? It is 1, right? 13 is at index 1. So you can ask for the index of 13, right? And tuple 2 dot index of, say, some element which is not present, 11. So it gives you value error because 11 is not at all present in this tuple. So it gives you value error. Tuple dot index x. Okay, x is not a tuple. So here x means this. Not x is not in tuple. 11 is not in tuple. When 11 is not present in this tuple, you cannot get the index of it. Hence, you get a value error. Make sense? All right. Now let us go back to tuple 1 again, which has some duplicate values. In these duplicate values, tuple 1, if I ask for the index of 1, 1 has repeated, which index it will give you? The very first occurred one's index is what it gives you. So the least index it always gives you if you ask. So 1 is at index 0, it is also at index 4. But you get a response as 0 because 0 is a first occurring index, first occurrence of 1. You see it here, right? So that is the reason you get 0 here. Similarly, if you ask for index of 2, it will give you 1 but not 5, right? So this is how index method works, right? So this is all about methods and functions that are applicable on tuples. The next one is traversing using loop. So how do you traverse through the tuple? Okay, this is a tuple, right? These are the elements of the tuple. How do you loop through each and every element of this? Say, for example, I want to find the sum of all these elements. I have shown you how to use a sum function for that. But if you want to do it individually, how will you do on your own? So for that, you can use a loop, and you can mention for e or x or anything that is just a placeholder in tuple one, right? For now, I'm printing e. You see, 1 is printed, 2 is printed, 3 is printed, 1 is again printed, 2 is printed, 9 is printed, 8 is printed, and 0 is printed. That means this loop allows us to loop through each and every element, okay, and access them. Make sense? Okay. If you know how to access each element from the tuple, you can perform any operations. Like, I want to find the sum of all these elements, or I want to find out how many even numbers are there. I want to find out how many odd numbers are there in this tuple. I want to find the sum of all the elements except ones. If it is one, I don't want to count for it. I want to count non sum of all the non ones in this tuple. All these things can be achieved once you know how to traverse through the elements within the tuple, right? Some cannot help you there because some will blindly sum up all the elements. But if there are any given conditions, I want to find out the sum of only positive elements in the given tuple. Some cannot help you out, right? So all such situations. Let us now find out the sum of all these elements in this tuple on our own. For that, you need to have a variable sum, right? And now you can access each element from the tuple. For e in tuple 1, what I need to do, I need to keep adding that to sum every time. Keep adding each element from the tuple to sum. Each element comes into e every time. Now if you look at sum, it is 26. If you ask for, if you use the function sum, it should also give you the same result. Tuple 1, yeah, sorry. Tuple 1, did I miss something here? Oh, sorry, this is sum and this is sum. It is crashing with this variable. It is not using the sum function actually. So, okay, got it. So, yeah, that is a reason. But if you look at the result of sum, where was that? I have just used on tuple 2, it is 54, but tuple 1, I did not use sum at all. But anyways, you can compute it on your own. This is 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 1 is 7, 9, 9 plus 9, 18, 18 plus 8 is 26, and that is how you see this 26. Make sense? Okay. So that is how you can find the sum on your own. And as I said, I want to find the sum of only even numbers, for example. Again, initialize sum to 0 and again start iterating. Right? But only if e is even. How do you decide that? Modulo divide. Sorry, I have to use colon there. For e in tuple 1, if, sorry, if e modulo 2 is equal to 0, then only add that e to sum. You are filtering out all the odd numbers. Now you can look at sum. It is just 12. Let us go and check. 1 is not considered because it is odd. Yes, 2 is considered. 3 is not considered. 1 is not considered. 2 plus 2, 4. 4 plus 8, 12. And that's what you see here. So once you know how to traverse through each element within the tuple, you can perform such operations on your own. You can write logic and eliminate some of the items or whatever you want to do, you can do, and you can achieve the goal, right? This is how you can traverse through each element within the tuple using for loop. Okay, and there is another way of using index. For that, You need to use range function. And how do you know how many elements are there in this tuple? You can use len function, right? And I just print. But what to print here? What if I print I? Because look at this carefully. Length of tuple 1, it gives you 5 for example. And if it is range 5, so replace this with 5. What is the value of I? I becomes 1. Sorry, I starts with 0, 1, 2, 3, 4. Because the argument to range is exclusive. So you will be getting, if you just print I, you get the indices, right? These are all the indices. Okay, 0 to 7, these are the indices. That means tuple has 8 elements in it, right? But I don't want these indices. I just need the elements within those indices. So to achieve that, you need to write the range of length of tuple 1, right? Print, what to print? Print the element that is at index I. I keeps changing as you have seen. I keeps changing as you have seen. Now you see what is there at index 0, 1. What is there at index 1? Because the next index is 1. What is there at index 1? It is 2. So 1, 2, 3, 1, 2, 9, 8, 0. 1, 2, 3, 1, 2, 9, 8, 0. This is how using index loop also you can traverse through a tuple. Alright. This is what you learned how to traverse using index loop as well as a regular loop of accessing through elements. Alright, next one is slicing. The next topic is slicing. Again, let us see what is there in tuple 1. Tuple 1 has these elements, and slicing is basically to access some portion of this tuple, right? That is what slicing means. So if you look at tuple 1, how will you do slicing? Slicing takes arguments like this. So the one is first one, what is the first index? Say for example, I give first index as 0 and I give the end index. This argument is the end index as 3 or 4 for example. Look at the output. You see the elements coming like this, which are nothing, which is a portion of this tuple. Okay, what do these indices indicate? These are indices. This index, this is an index. So what you are asking for is starting from 0th index. Okay, this is 0th index, first index element, second index element, third index element, fourth index element, fifth index element, seventh index element, and eighth index element. Correct? 0, 1, 2, 3, 4, 5, 6, 7. Sorry, 0th index, first index, second index element, third index element, fourth index element, fifth index element, sixth index element, and seventh index element. So you have indices ranging 0 to 7. All right. Now what did you ask? Please start with 0th index, means from here, and give me everything up to third index. Remember, this 4 is exclusive, meaning give me everything starting from 0 up to third index only. 0, 1, 2, 3, third index only. 4 means don't consider 4. Anything before 4 is what you are asking. Starting from 4, starting from 0th index, anything before 4 is what you are asking. That is how you have to interpret this. This is how you got this. Now, another one. What if you have asked for elements indices 0, 2 to 6? Guess. At the second index. At second index. So, at second index, what is it you have? What is the element you have at second index? 0, 1, 2. Right. Second index you have 3, and you need to go up to fifth index because 6 is exclusive. 3, this is second index, third index, fourth index, and fifth index. So you should get 3129. 3129. Remember, when you slice a tuple, you will get another tuple. When you slice a tuple, you get another tuple. Here also. You did a slicing on tuple, you got another tuple, right? What if I have to access all the elements? But look at this. This is the starting index. I have omitted the starting index. Always it assumes to be 0. I have omitted the ending index, which assumes that it is a length of the tuple. So you'll be getting the entire tuple as it is. You'll be getting the entire tuple as it is. The other way to achieve this is explicitly mention 0 because starting index is 0, and then you put length of tuple 1 here because length of tuple 1 is exclusive. This is exclusive, right? So you'll be getting 8. 8 is exclusive, it means you are asking for anything between 0 and 7 technically. Other way of asking this is you are asking for 0 to 8. So all these are one and the same in this example, right? This one gives the same input, same output. This also gives you the same output. This also gives you the same output. So if you have to access the elements from a tuple, directly mention the name. The other way of doing that is using slicing. If you have to do, you just put a colon there. Starting index is assumed to be 0, ending index is assumed to be the length of the tuple. That also gives you the same result, right? Well, interestingly, using slicing, what you can also do is reversing of a tuple. Just like how you were using this technique to reverse the elements in a tuple in a list, you can do the same. If you look at this, right, tuple 1 initially was like this, but now it got 0, 8, 9, which means these elements have been reversed 0, 8, 9, 2, 1, 3, 2, 1. So if you have to reverse a tuple, this is the simplest way to deal with. All right. So this is all about slicing. And one important point about slicing is that what if I ask for elements from 1 to 100? Do you really have 99th index in this? No. Still, slicing works for you. It doesn't throw you any error like index error or anything as such. So what it considers is the minimum of when it is ending index, it considers the minimum of what user has provided versus the length of the tuple. Whichever is minimum, it considers that. Hence, you don't get any error over here. Okay. And the other thing I want to really talk about is I just ask for like this. So starting index I didn't provide. So as I said, starting index is always assumed to be 0 if it is not present. So 0 to third index you are asking. 4 is exclusive. So 0 to third index 0, 1, 2, 3 means this is what you see here. This is what you get. Makes sense? Similarly, if you ask for third index everything, what is there at third index? 1 is there, right? 0, 1, 2, 3, third index. From here, everything till end, because you did not mention the ending index, it considers everything from there. So 12980 is what you see here. This is how you can slice a given tuple and you can create new tuples from that. All right. With that said, let's move on to the next topic, which is concatenation and repetition. Yes, what is concatenation? So let us look at what is there in tuple 1. Let us also look at what is there in tuple 2. Yes, there are certain items in tuple 1 and certain items in tuple 2. What if I want to club them together and create a new tuple? That is possible using concatenation, the plus operator. And now if you look at tuple 3, you see a single tuple created with all the elements. So all the elements from tuple 1, all these elements have been considered first up to 80, and all the elements from tuple 2 have been just appended at the end. So this is the operation of concatenation. Okay, this is concatenation. And if you want to repeat this, you can say tuple 4 is tuple 3 plus tuple 3, right? Meaning you have repeated tuple 3 elements. You see, already this has these elements. The same elements will be repeated. Up to here, this is what you already have, and you have appended the same tuple to itself. So the same elements have been repeated. Make sense? Okay. Now, instead of doing this, you can also use repetition operator. So that is nothing but star. Let me take an example again. This has become very big. So this is just tuple 1, right? I want to repeat these elements again and create another tuple. For that, what you can do, tuple 5 or something is equal to 2 times. I want to repeat these same elements twice. From where? From tuple 1. Now what you see in tuple 5, you see these elements repeated twice. This is first time, this is second time. So this is a repetition operator star. Concatenation operator is plus, repetition operation is star. A simple example, if you have tuple 1 with only one element and I want to repeat this for 5 times, how do you write the statement? Tuple 6 is equal to 5 times you want to repeat, no? 5 times of tuple 1. And what is there in tuple 6 now? You see the same element 4 has been repeated 5 times, right? And tuple 7 is tuple 1 times 6, tuple 7. You see, you can use tuple as a first operator or second operator. Here you have used it as a second operator, here you have used it as a first operator to this star. Both of them work, both are allowed. So what you're asking here is consider tuple 1. Yes, tuple 1 has only one element in it now. And repeat that tuple or the elements within that tuple for 6 times. So 4 has repeated for 6 times. This is how you can create new tuples using repetition. This is all about concatenation and repetition on tuples. The next one is packing and unpacking. Very interesting topic again. So let us create a tuple with some numbers. Let's not repeat the elements for now intentionally. Okay, all right. So this is a tuple, and if you print tuple 1, you can see all these elements, right? Now, okay, this is too big for me to explain. Okay, let me consider only 3 elements or 4 elements: 12, 14, 17 and 56. Now, tuple 1 has all these elements. All right, tuple is a single variable. Remember that. We started this discussion with that concept only. What you cannot create hundreds and thousands of variables Hence, you can have a collective name to that collection of elements. That is one of the such data structure in Python is tuples. All right. Now, what did I do really is I have considered different values, different elements, multiple items, and I have put them together into a single variable name, which is a tuple one, which is tuple, right? Tuple type. This is nothing but packing. Packing means you take different values or different items or different elements and put them together to construct a tuple. This itself is packing. Then what is unpacking? What if I want to assign these tuple values to different variables? How many variables I need? I need four variables, right? Because I have four values in tuple one. So what I need to do is I need to mention four different variables and then mention the tuple name on the right hand side of assignment operator. Now if you look at A, what is there in A? 12. One element. What is there in B? They will be assigned in that same sequential order. B has 14. What about C? C has 17 and D has 56. What is the type of A? It is just nothing but an integer, right? So this is your tuple and you have taken each item from this tuple and assigned to individual variables. And this is called unpacking. Makes sense? This is called unpacking. So packing means considering multiple values and putting them together into a tuple. That is packing process. Unpacking means taking the tuple and split individual items of that tuple into individual variables. This is unpacking. Okay. All right. So now, what if you have what is there in tuple one? These are the four elements. What if I just mention only two elements? You see, it's a value error. Too many values to unpack. That means this tuple has many values than the number of variables you mentioned on the left. This tuple has four elements, but you have given only two variables. So it's not possible for me to unpack is what it is saying. So in such situations, you'll get an error. The other situation where you can also get an error is you have given more elements than the number of items present in the tuple. You see, but the error message is different, but it is still the value error. Not enough values to unpack. That means this tuple has no enough number of elements in it to unpack into these variables is what it says. Tuple has only four elements, but you mentioned five elements here. Hence, this results into not enough values to unpack. So the thumb rule is if you are using unpacking like this, the number of variables that you mention on the left should be same as the number of elements that are present inside the tuple. But what if I don't know how many elements are there in the tuple or I want to write some generic code? That is where extended packing helps you. What does it mean really? You see, there is no error, but all that I have done is between this statement and this statement, what is the difference? I just added star before B. What does it really mean? What is there in A? A has a value 12, which is a very first element, which is fine. What is there in B now? See, B got a list of elements. List. Very importantly, this is a list. This is not a tuple. B got a list of elements. What are these elements? Except 12, because 12 has been already assigned to A. Rest of all the elements have been got into B as in the form of a list. So this is called extended packing. Okay. So another example I would like to give you is what happens in this case. I have given three elements here and but tuple has four elements. What happens in this case? Well, let us look at it. A tuple 1 A is first element 12. What goes into B will come to this later. But after this, you have one more A variable. This variable will get the last element because this is the last variable here. So 56 will get into C. 12 has gone, 56 has gone. What is left over? 14 and 17. And this 14 and 17 as a list will get into B. Let us examine it. A is 12, B as a list 14 and 17, and C gets 56. This is how unpacking can be done using extended packing. Extended packing. What if I write a statement like this? This is not possible, right? So you have to use a star if and only if you have at least two elements as I have given you, as I have given you in the previous example. This is possible. Now if you look at B, except the first element, everything will be coming into B in the form of list, right? All right, clear. So this is all about packing and extended packing on tuples. And the last one is nesting of tuples. Let us look at this carefully. Sorry about that. What is nesting? Okay, first of all, what are the practical examples where you can use tuple, right? First thing, as you have clearly seen, tuple doesn't allow you to change the values. So whenever you want to store something that is not changeable, you can use tuple. Examples, week names of the weekdays. Names of the weekdays are fixed, and there will be only 7 days in a week, and their name will not change in general. For that, you can create a tuple. Okay, weekdays are again string types, right? So you can create a tuple with weekdays. All right. Now look at weekdays. Yes, this is what it is. And if you want to access each and every weekday, you can write something like X or anything you can put for a day in weekdays. Yes. What to do? I just want to print for now. Print what? Print the day. You see, all these items of this tuple have been accessed and printed one after the other. So I don't want to insert a new day inside this, or I don't want to delete a day inside this. In such a situations, you use tuple rather than a list, right? And if you take the same example of a class of students, right? What is that doesn't change for a class of students, right? Assume that you want to store the details of last year students, right? If it is a students from last year, um, probably their roll number won't change because it has already happened. So their roll numbers can be stored in the form of tuple, right? Like this. Or you want to store the roll numbers of the students who have participated in sports. Then there is roll numbers may not be in order, right? So such things you can store in tuples rather than lists. Once you store them in tuples, the event has already happened, right? Whatever the number of students that have been participated in sports, that roll number list, the set of roll numbers is what you already know, and in future that won't change because that event has already happened, right? If you store them in list accidentally, you can change that list and add a new roll numbers or delete existing roll numbers. That is possible accidentally or intentionally. To avoid that situation, if you store this data in tuple, then tuple doesn't allow you to change the elements within itself, right? So all such situations are good examples of using tuples in real time. All right. And you can use tuple to represent one student record. How is that? So I say S1 is a student, and I am going to create a tuple with his roll number, his name, okay, and his age, maybe 6 years, and oh, sorry, I need to close this string, and also his gender is a male student, and I also want to store whether he has been promoted or not. I want to store whether he is promoted or not as a boolean. Yes. Now, if you look at this student, this is the data. So once you store this, you cannot change this. Okay, say for example this is a last year student information. So 101 was his roll number, and it will continue to be there forever. His name is Avi, assuming that his name doesn't change in future, right? And I want to create second student also. His roll number is 102, and his Bharat is also a male student, and he was not promoted unfortunately. So you can create false here. Similarly, I want to create another student with roll number 103, and name is Bhavana, and a female student. She got promoted. All right. Now, if you look at these students, this is how you can get the information. But what if I want to create a class with all these students, right? I want to create a tuple. You can just say like this: S1, S2, S3. Sorry, class is a keyword. You cannot use keywords as variable names, if you remember. So as you see here, what happened now? You got a tuple here, you got another tuple here, you also got another tuple here. But all these three tuples have been enclosed within another tuple. So now class UKZ becomes a nested tuple. Okay, class UKZ becomes a nested tuple. Having tuples within another tuple is nothing but nesting. Okay, so this is a tuple, but it is part of another tuple. This is also a tuple, which is part of another tuple. This is a main tuple, right? Outside tuple. This is also a tuple, which is also part of the another tuple. So class UKZ is a nested tuple, and S1 is not a nested tuple because it has integer, string, integer, string, bool. Here it has integer, string, and bool. But when it comes to class UKZ, it is of type tuple, but it is a nested tuple. Nested tuple. So nesting means you want to just store all these elements, right? You want to store all the items of a tuple. If they are tuples already, then that would become a nested tuple. This is the concept of nested tuple. Now you tell me, if it is S1, just not a nested tuple but a plain tuple. If I ask for S1 of 0, what is output I get? This is the content of S1 tuple, and I am asking what is there at index 0. What is there at index 0? It is 101. So you will get 101 over here, right? Which is the roll number. Similarly, what if I ask for the one that is at index 1 in S2? S2 index 1, it is Bharat. So you will be getting Bharat. Make sense? And in S3, you may have what is that you have at the last index of S3, it is true. So you'll be getting true over here, true here. So this is how you'll be having these indices working on these individual tuples, as you already know. Now, what if I ask for zeroth element in nested tuple? Interestingly, it gives you the entire tuple. Why? For this class UKG tuple, this is all the zeroth indexed element. This is a first indexed element. This is a second indexed element. So you have asked for zeroth indexed element. So you'll be getting this entire tuple as output. Now, what if I have to access the name of this student? So this gives you the entire tuple, but within that tuple, you need to access the name is at index 1. So you need to mention this way. That is when you will be getting Abhi. Does it make sense? So here you have two levels of nesting, right? One level of nesting, but outside there is nesting. So you have to use two indices. First index will give you that entire tuple at that particular position or the index, and the second index acts within that tuple to identify one piece of information in this example. So that is how you can access using multiple indices. Now, what if I have to get all the names of the students in this class UKG? How can I do that? For name in, sorry, not name, it is directly. It is a tuple for T in, or for, yeah, for T in class UKG. What is T now? In the class UKG, if I ask for T, what does T hold? It holds this entire tuple. And what I need to print now? T means one entire tuple now, right? So I can say within that T, whatever is there in index 1, you print that. You see, you got Abhi, you got Bharat, and you got Bhavana, which are the names of the students. So from this nested tuple, you have accessed all the names. How? Using a loop. Okay. You have used a loop to access the elements from the nested tuple, right? Because when you get into a loop, this T refers to the entire tuple within that nested tuple. So you have the context of that entire tuple. Within that tuple, you need to have one piece of information to grab. That is first indexed element. So that is how you'll be having Abhi, Bharat, and Bhavana. What if you directly print T? Guess what happens? What will be there in T? You print T. T refers to the entire tuple, right? So this is a first student information, this is a second student's information, and this is a third student's information. But within every instance of that student, I want to access only the names, which are always at the first index. So I have accessed this. How do you access whether the information about whether the student got promoted or not? Means promoted or not is the last element always. So what you can do, you can use this same loop, right? And you can print T is the entire student information, which is one tuple. You can access the last element using -1. So you can see true means promoted, false means not promoted, right? So this is how you can use loops on nested tuples, and you can access the data. All right. This is about nested tuples or nesting of tuples. With that said, we reach the end of session 10. This is primarily focused on tuples, and stay tuned for next session.